Hello. All right, we're continuing on with probability. Again, this lesson focusing on experimental probability, which is what actually happens when you're doing your experience or experiment. And again, we can also call this the relative frequency. So theoretical is what we expect or kind of what the numbers tell us it should happen. And experimental is exactly what happened in our experiment. Talia and Yoshi plan for 1 out of 8, 12.5% of the players winning a prize. During the fair, they kept track of the numbers of total players and winners and recorded the data in the table. How does the actual number of winners compare to the expected? So again, those are some keywords: actual number versus the expected number. So again, experimental / relative, and this is theoretical. Probability of a red. So if we're thinking about, let's see here. Red. During the fair, they kept track. I'm trying to think of what that red means. Okay, well, we're just going to skip that, because I don't know what that means. I guess that would mean it's got a 0%. All right, so if we look at 10 a.m. to noon. 10 a.m. to noon. Let's just get rid of this whole thing. $10 a.m. to noon. All right. How does the actual number of winners compare to the expected number? So the total players were 213. So I'm going to put that on the bottom. And my winners were 22. So this gives me a probability, if I use my calculator, 22 divided by 213, about 0.1033 or 10.33%. So our expected was 12.5%. So this is less than expected, and it's about a little over 2% less. From noon to 2 p.m., we had 36 winners on 262 contestants. So here, 26 divided by 262. This gives us 0.0992. Oh, 36, excuse me. I got to redo that. 36. So 0.1374. So this equals 0.1374 or 13.74. So this is about 1.24% more than expected. So there were more winners. And if we looked at our total, we found that we had 58 over 475. So let's see here. And we got about 12.21%. So 0.1221 or 12.21. So I would say that this is really close, slightly under our expected. So really close, slightly less than expected. So I would say that 12.21% is pretty, let's get a different, is pretty close from 12.4%. So the results were really close to their predictions. I would agree with that. Joaquin also kept track of players and winners for his game during the fair. Based on the results, how many winners should he expect if 300 people play his game? So again, he had a little bit 16.1%, a little bit more at 17.8, and so he had a total relative frequency about 17.1. So if we wanted to figure out basically, hey, if we have 300 people total, what percent is that if we use 17.1 out of 100? So one way to do this is to set up a proportion, cross multiply. 100x equals 300 times 17.1, 5,130, and then divide by 100. X equals 51.3. So I could say, again, you can't have 0.3 of a person. So Joaquin could expect around, what was that? I like to round up when it's people because you'd rather have a little bit more than a little bit less. But it could be around 51 or 52. Another way you could just do it is to move 17.1% to a decimal and then multiply it by your total. So again, 300 times 0.171 should give you 51.3. We can double check. 300 times 0.171. 51.3. So depending on what you want, how you want to solve it, there's two different methods to solve it.